Okay, this is 16.1, number 4, a much more difficult vector field to plot. The reason this one's so tricky is because both the x and y component of the vector, which are the location where these vectors will be plotted, neither one of them is going to return the same value as you input. Now, generally that's not a problem, but in this case it really is. If we're going to use x, y coordinates, and we do the typical 0, 0, 0, 1, 1, 0, 1, 1, so that we sort of surround the origin. Well, what these functions do with these is transform them, and then we end up with x and y coordinates here, which may all be in the first quadrant, or maybe on the axes. That is, it literally translates the input coordinates to new coordinates, which is where these vectors will then be plotted. And so it's really hard to get a sense of what the shape of the vector field is, because you want to deliberately pick points in locations, and that's really hard to do because the input on x and y doesn't necessarily translate to that being the location of the vector you're testing. So things like this are much better tested with technology. You can either take a spreadsheet and then do a wide range of positive and negative values for x, also for y, have a column that programs sine x, cosine x, and then finally it will output to a graph of what the sine x versus cosine x column looks like, and you'll get a pretty good output of this. Of course, the Sage cell is going to do that for us automatically, and for this particular one, this is what that looks like. And as you can see, it's sort of a series of nodes where the vectors are either fleeing or moving towards those nodes and increasing and decreasing in magnitude as a result. So complex vector fields like this, much better done with technology.